Hello, today we are going to learn about electrostatics. Now, this is going to be particularly useful to students of class 12 in ISC or CBSE board. However, anybody wishing to learn about electrostatics from scratch will also find this discussion useful. So let's get started. Now, we'll try to go through this course firstly by asking some questions. Firstly, we'll try to understand whether it is possible to bend a stream of water with a PVC pipe or not. Now, we can try to understand this question theoretically, or we can try to do it hands-on and realize it for ourselves, as I have tried to do over here. So I had taken a PVC casing which was rubbed previously with the help of a piece of cloth. And you can see in this video over here that as I bring it close to the stream of water, it gets displaced. Now have a look at it once more. I bring the PVC casing close to the stream of water slowly and it gets finite displacement. Now why is it that it happened like that? In order to understand that, we'll have to go through this chapter on electric charges and Coulomb's law. Over there, we'll try to understand what is meant by electric charges, how is it that they interact among themselves, what role does Coulomb's law play in this interaction, and so on. After going through this chapter, we will try to understand how is it that a person can stay protected inside a Faraday cage from intense electric fields. Now, in understanding this question, the chapter that will help us is the chapter on Gauss's law and its applications. Over there, we'll try to understand what is meant by Faraday cage, how is it that it can offer protection to someone from intense fields, by what principle. All those things will be clear to you. After that, we will try to understand whether it is safe to touch an object at a potential which is as high as hundreds of kilovolts or not. The chapter that will deal with this and many other allied concepts is the chapter on electric potential. After that, we'll try to see how is it that electrical energy can be stored in space. The chapter that will help us in understanding that is the chapter on capacitance. So these are roughly the chapters that we will cover in our discussion on electrostatics. However, this is going to be quite an elaborate discussion, and as a result, we are going to further divide these chapters into two parts. The first part, part A, as you can see, is going to cover electric charges and Coulomb's law and Gauss's law and its applications. So this chapter and this chapter will be a part of part A of our discussion. For part B, you can understand that you will be having electric potential and capacitance, and apart from that there will also be a chapter which will deal with the numerical problems of both part A and part B combined. So numericals will definitely be there, and that we will cover in part B, where we will take up all the numerical problems of this course on electrostatics. So that is how we will go through this course. Now let's try to understand what are the topics, what are the points that will be covered in each of these chapters. First, let us try to begin what will be there in electric charges and Coulomb's law. So we will get started with the introduction to electric charges, and then we'll try to go through the definition of 1 Coulomb, what is meant by that, what is also meant by electric charges. We will go through all their properties in detail. And after that, we will go through what is meant by Coulomb's law, what is it, what are the factors on which it depends on. Then we will cover electrostatic induction, which is a process of charging which does not involve any contact. Having understood that, we will try to go through the principle of superposition, which is nothing but the way in which multiple charges interact among themselves. And last but not the least, we will definitely go through the numerical problems of this chapter, something that will help you in understanding the theoretical concepts that will be covered in a better manner. Because I truly feel if you go through both the theoretical understanding and apply them in numerical problems, then only you have your concepts cleared properly. So that is what we will cover in this chapter on electric charges and Coulomb's law. After that, so this is how this will be done. After that, we'll be having Gauss's law and its applications. And over there, the topics that we will cover, firstly, we will go through this very new physical quantity called electric field. We'll try to find out the electric field for different types of charge distribution, starting firstly with a charge ring. And then we will try to discuss lines of force. Now, this is a concept which I'm sure you must have encountered in magnetism as well. Over there also you had come across lines of force, and here also you'll be going through them, but here there will be a slight difference in the lines of forces, how they would be behaving. So we will certainly try to go through that difference and try to explore it in great detail. And after that, we will go through this new concept called solid angle. Using this concept, we will try to understand what is meant by electric flux, and with the help of the knowledge of these two things, we will be in a position to understanding Gauss's law and how it can be related to Coulomb's law, the two very fundamental laws of electrostatics. Now, after learning that, we will be applying Gauss's law in different kinds of charge distributions, like let's say infinite line charge, and then there is plane sheet of charge, and then there will be spherical shell as well. And after that, we'll be also going through our discussion on uniformly charged sphere. So that is what we will try to do. Having understood that, we will also try to understand what is meant by electric dipole. The electric dipoles are very crucial in understanding the behavior of certain molecules which have what is known as the dipole moment, and that is why we will try to understand how the electric field behaves in various positions, such as along the axis of the dipole and along the perpendicular bisector of the dipole. Now, having understood that, we will try to go through our understanding of the behavior of the dipole in an external electric field, how it experiences a torque in external electric field, and lastly, we will certainly go through the applications of what we have learned so far. So certainly we will cover the numerical problems of this chapter in great detail. And that is going to be our standard procedure, that we will go through numerical problems of each chapter at the end of it, so that you have a comprehensive understanding of the concepts and you gain confidence by applying those concepts. So that's what the second chapter would be on Gauss's law. And this will mark the end of part A of our discussion. In part B, we will start our discussion with electric potential. So in electric potential, we will get started firstly with what is meant by electric potential. So we'll go through the definition of it. We'll try to find out the potential of an isolated point charge, something that we had done before in a way, because we had found out the electric field of an isolated point charge, and we will see how that knowledge will come in handy over here. From there, we will also try to understand how potential of an electric dipole can be found out, and how the knowledge of the potential of an isolated point charge can help us in getting the potential of an electric dipole. Also, we will explore how the relation between electric field and potential over here. Now, electric field and potential are quantities which will come hand in hand, and it is extremely essential for you to understand the link between them. So that is what we will try to understand, and I think in a way we will try to understand how physics works, because in physics you will go through different types of physical quantities, and it is extremely essential for you to appreciate and understand the relation between them in order to truly understand how physics works. So that is definitely what we will try to do. After that, we will go through equipotential surfaces, something which will help us a lot in understanding how conductors behave later on. And then we will go through electric potential energy. Now, you have definitely come across gravitational potential energy when you had gone through gravitation. Now over here, it's a different kind of interaction, the interaction between charges, and here also there will be potential energy that will be present, because this is also a conservative force field that we will consider. So that is what we will try to do. And then what is the work that is done in rotating a dipole? That is also something that we will take up. And then we will try to find out electric potential due to a spherically symmetric charge distribution. Now, we had already found out the electric field due to a spherically symmetric charge distribution when we had we would be dealing that in part A in Gauss's law and its applications. And over this, you can think of it as just an extension of that, but from the standpoint of electric potential. So that is what we will do, and then we will go through the properties of charged conductors, and that is something that will enable us to gain more insight into this incredible class of materials. Finally, we will go through the numerical problems of this chapter, something without which our discussion on any chapter will not be complete. So this is how we will go through the chapter on electric potential. Next, we will have the chapter on capacitance. We will begin our discussion firstly with what is meant by a capacitance, the definition of it. And then we will go through understanding the capacitance of an isolated spherical conductor, just like how we had found out the electric potential and the electric field of an isolated charge. And then we will explore how we can find out the parallel plate capacitor case, how we can find out the capacitance of that. And then we'll try to see how the potential energy of a charged conductor can be found out, because that is going to be essential for our analysis later on, where we will see how the charge distribution between two conductors can be studied. So after that, we will see what happens when we combine multiple capacitors both in series and parallel, and you can compare whether this reminds you of how resistors can be combined as well in series and parallel, and see whether they are exactly alike or not. After that, we will try to see how the energy loss, something that I was just talking about a bit earlier, energy loss that happens during redistribution of charge when you have two conductors coming in contact with each other. And that is going to be very similar to how, let's say, two objects collide. I'm sure you must have encountered that in mechanics, that particularly in case of inelastic collision, you know how there is energy loss when two objects collide. So this is going to be the electrostatic counterpart of that in a way. And I think that's one of the beauties of physics, that you can relate apparently disconnected topics in this wonderful manner. And you can truly appreciate the beauty of physics in that way. So that is something that we will try to do over here as well. After that, we will go through this concept of dielectrics and polarization, the concept that is needed for the very working of the capacitors in general. Their ability to store charge depends upon understanding this concept. So definitely we will try to go through this. And then we'll understand what is meant by dielectric constant and what is the value for it for a conductor. Why is it that it's so special? And then we'll try to see how that can be applied in case of a composite dielectric where the capacitor comprises of two dielectric media, and we can extend it to multiple dielectric media. And finally, of course, we will be having a discussion on the numerical problems, on the applications of what we have studied so far. And after that, as I have mentioned before, there will be a chapter solely on numerical problems of all the chapters that we have done so far, which means Coulomb's law, and then Gauss's law and its application, and then electric potential, and then capacitance. So all these together will, the numerical problems of all these chapters will be taken up in another chapter, which will deal with only numerical problems. So that is also something that we will do. So if you have to refer to the books, then you can refer to these books. I'm sure they will be helpful to you, and I'm sure you will gain confidence also after going through our discussion. We know that, of course, understanding the concepts is not fully, it's just not the understanding of concepts that's required, it's their application is also required, which is why we have taken up numerical problems in each of the chapter. To enhance your understanding, there will be a further set of numerical problems and solutions available to you, so that you can gain more confidence in applying those concepts. So I'm sure those will also be extremely useful to you. So I'm sure that you are looking forward to learning electrostatics with me. Well, I'm also looking forward to it. So I'll see you around. Thank you and take care. Goodbye.